Hi guys, welcome back to the video. Today we're going to be solving an extremely difficult problem, so let's get right into it. Alright, so the problem is defined as such. We're given three circles right here, and they're intersecting like this. There's a point right here where they touch, and their centers lie right here and right here. Now, the radius of each circle is 4, just like this. And that is in fact all that we are given. The question now becomes, what is the area of the red region? It looks like a quite daunting problem, but the solution is extremely elegant, so trust me, stay till the end of this video. So there are many ways of solving this, but I'm going to use my favorite. I like to divide this up so we can approach one part of this problem and then simply multiply at the end to get the other answers, or the full solution. So if I divide it up like this, you'll notice we have 4 equal regions. These are all of equal area value. So if we find any one of them, we can multiply by 4 and we have our answer at the end. For this part of the video, we're going to be focusing on only one region, and we're going to call this region R, let's say. So let's call this specific region right here, region R. As I said, you can multiply by 4 at the end and we get our total answer. So to find this region, there are a variety of methods, but I'm going to be using the most conceptually easy, and I recommend you check out some other channels. They have different methods of doing this. Okay, so number one, to get the region in the first place, what I think we should do is begin with getting the quarter circle right here. So the idea of our solution is going to be getting the quarter circle, and once we have that area, we're going to simply subtract this area that lies inside that is not part of the red region, and once we do that, then we have our answer. So let's begin with that. I'm going to be labeling the region R as such. R is equal to what? First, the quarter circle. So the quarter circle is just 1/4 pi r squared, pi, and our radius is 4 squared. And now I have to subtract this entire region. And by the way, I'll be doing this right here so you can see a little conceptual of what this solution looks like laid out. So that's our quarter circle. Now what we're trying to subtract is that, which is you can't really subtract that all in one go. But we can subtract it in chunks. A major chunk of subtracting this would be this sample. So if I drew this purple line from here to here, and I draw this curved line, which is also purple, you'll notice that we get to subtract a great deal of that big sector, or that big region, which we have to subtract to get our red region R. So once we subtract this purple region, all that's left is to subtract this sort of wedge, and once we do that, we've subtracted that entire region, and we're only left with R. So we'll get back to this yellow region right here in a little bit, but let's first subtract this purple region, highlighted right there. So that is a sector, as you can see, because there's curvature right here, and it's defined by those 2 straight lines. And it's actually starting from the center of the center circle and going to the edges of the circle. So our area of a sector is as follows: 1/2 r squared theta. Theta must be in radians. It cannot be in degrees. So any degrees that we find, you have to convert that into radians. Now the issue is we have our r, which is 4, because it's beginning from here and it's going to the end point of the circle, making it a radius. But we don't have our theta. Let's see how we can find our theta by looking closely. If we look real nice right here, we'll notice this is the beginning of this line for the sector, and we were trying to find this angle right here. What is theta equal to? Question mark. So we can look at this line right here, straight. We know that this is a radius because it's going to the end point of the circle and it starts at the center. So we know that that length is 4. Now check this out. If you go from here to here, this is also 4, because if you zoom out and look at this circle on the right hand side, that's the center and that lies on the circle as well. So this means that the side lengths of this triangle that we just created are 4, 4, and 4, making this equilateral. That means that the angles themselves are 60 degrees, 60 degrees, and 60 degrees. Super elegant how we can just figure that out. So now we have our theta right here, because if I remove this equilateral triangle real quick, you'll notice that the area we were trying to solve for was that pink area, and now, via that method, we have 60 degrees. I'll leave that equilateral triangle because we'll need it later. So we have our theta. 60 degrees to radians is just equal to pi over 3, because we can use our radian formula. This is equal to pi over 3 radians. So we can now subtract our sector right there. See, for the conceptual visualization, we have our r is equal to the semicircle, or not the semicircle, the quarter circle, and we subtract our sector right here. And now all that's left is to subtract one more thing. What do we have to subtract now? We have to subtract the wedge we were talking about earlier. So if I draw this line, I draw this line, you'll notice this area defined right here in yellow is all that's left of what we have to subtract to get our region R. So let's figure out how we can get that region in yellow. This is probably the trickiest part of the video, but it's actually quite obvious. So you can pause it right here. I didn't get it my first time, but yeah, check it out. So here's the solution. The way of doing this is quite elegant. If I were to remove this equilateral triangle, so you guys can see better, if I did this, if I just clean this up a little bit, so let's see. Let me draw a line from here to here, and we have this. You'll notice I just outlined a sector of the right circle that was very similar to our previous sector, which was facing like this, going the other way. So if I highlight this area, you'll notice that this sector that I just drew includes the wedge that we were referring to, and I'll put it in the yellow again, in yellow. So how can we isolate just that wedge in order to subtract it? Because we're trying to subtract the wedge, right? How can we do that? The method of doing it is actually, the method of doing it is finding the area of this entire sector, just like this. And once we have that area, just subtract the triangle from it, and you'll be left with only this area. So if you didn't catch that, the area of the wedge, conceptually, is equal to the area of the entire sector, like this, minus the equilateral triangle that lies inside. Just like that. And if you don't believe me, check this out. If I put it in here and we were to subtract them, you're going to get that wedge area again. So this works. Now, how do we find the area of this sector right here in this diagram? It's the same principle. This angle right here was 60 degrees because of this equilateral triangle that we created. 60 degrees, you can see it right here. It's 4, 4, and 4 on all sides. So we have that, and this radius is 4 because it's going from here to here. So we can use this to our advantage. We can now write the area of the wedge up here is equal to the area of the sector, which is what? We have 1/2 r squared, 4 squared, theta, which is pi over 3 again. And now we have to subtract the equilateral triangle. So minus the equilateral triangle. What is the area of the equilateral triangle? Let's take a look. Oops. Oh, whoa. Let's try this. Well, that's strange. Let me fix that. So the area of the equilateral triangle is easy to figure out. We know that the sides are 4, 4, and 4. Very simple. You can simply draw a line right here, which is the height of the triangle. And then we have two sides, 2 and 2. And now we have a 30, 60, 90 triangle. So that means that this is 60, this is 30, and this is 90, meaning that the altitude of this triangle is equal to 2√3, because it's just the bottom number multiplied by √3. So with this new knowledge, we can write the area of the whole triangle as such. We're going to have two halves, so this half and this half. We have 2 times a 1/2 base times height, so 2, and then the height is 2√3. So area of triangle, 1/2 base times height, and then we have 2 triangles, so like that. These cancel, so you have the area of the triangle is 4√3, just like that. Now you can use that to find the area of the wedge. Now that we have the area of the triangle, we plug that in, because remember, the area of the wedge is the area of the sector, which is this, minus the area of the triangle. The area of the triangle is 4√3. We can simplify that. We'll simplify after, actually. So now that we have the area of the wedge, we said the area of the region R is this, where we subtract the wedge. So we can just plug that in for the wedge now. The wedge, as we said, was 1/2 4 squared pi over 3 minus 4√3. That is the area of this, and we're subtracting it so we can get the area of R. So all we have to do now is simplify. I'll use red. r is equal to what? What is 4 squared? 4 squared is 16. 16 over 4 is 4, so we have 4 pi. And, oops, 4 pi. Now, what is this? We have minus. Oh, same thing here. 4 squared is 16. 16 over 2 is 8. And then we have 8 pi over 3. So minus 8 pi over 3. Let's see here. Maybe I'm missing something. Because, let's see. So we have our area of the quarter circle, which is corresponding. And then we have the area of the wedge here. It looks like I forgot to add or subtract the area of the sector right there. Let me take a step back. So let's add that in. The area of that sector, which we were referring to, which spans from here to here and then down. So this entire area, which is curved like that, that was the exact same sector we were referring to. I think we even solved for it somewhere, but maybe I forgot to write it. So the area of that sector is what? That equilateral triangle we were referring to is 60 degrees, so that's pi over 3. And then we have the radius is 4, so it would be minus 1/2 r squared, 4 squared theta, which is pi over 3, which is corresponding to that sector. And now the wedge would be that long yellow thing which we plugged in right here. So now we have all of our components. We have the quarter circle, we have the sector, which we're subtracting, and we have the wedge, which we figured out like that. Okay, now let's continue simplifying. If you continue simplifying, it turns out that we simplified this correctly, but this simplified is also 8 pi over 3, so that works out nicely. And if you simplify this now, you have minus 16 over 2 is 8, and then 8 pi over 3 again. So this becomes r is equal to 4 pi minus 8 pi over 3 minus 8 pi over 3. And then we have plus 4 root 3. And now let's just simplify. Our region R becomes what we have. Let's multiply by 3 over 3. This becomes 12 pi over 3 minus 16 pi over 3. We have negative 4 pi over 3 plus 4 root 3. That is our region R. So we finally figured it out. We used our simple method. We got the quarter circle, we got the sector, and we got rid of the wedge through all those methods. Now that we have R, we just have to find our total region, which we'll call A, which is equal to 4R, because we have 4 red regions. We have 1, 2, 3, 4. So let's multiply this out. Area is equal to 4 times 4 root 3 minus 4 pi over 3, which is equal to 16. 16 root 3 minus 16 pi over 3. Ladies and gentlemen, this is actually our answer. Yeah, we've done it. This was a quite daunting problem, but hopefully it wasn't too confusing. If I made any mistakes, let me know in the comments down below. I hope you guys enjoyed. If you have any questions, feel free to ask. Yeah. Thank you guys. See ya.